And I'm a little bit struggling in finding the right words because it's impossible to find the right words to appreciate how you keep up in this heavy situation for months already. So that just keeps me deeply humbled what you are doing here. And it again proves that the Israeli innovation ecosystem is outstanding in any kind. So I'm really honored to be invited to speak in front of this distinguished audience. Yeah, you all have, of course, experienced the boom of AI, and as you can imagine, AI also has infected this feather, automotive industry, and of course also Volkswagen Group. We as a group innovation, that's my responsibility, have somehow an international footprint, of course. We care for all the brands of the Volkswagen Group, all the passenger car brands so far. And when we talk about Connect, our Israeli branch, which we are so proud of and proud about, they also care for the truck colleagues. The scope of group innovation covers the whole field of mobility as a whole, coming from sustainability or the mobility topics, and of course everything about AI and digitalization. And that will be my focus today. So when we talk about AI, our AI feather somehow, then it's about, of course, autonomous drive. It's about digital customer interface, and a huge new topic for us is, of course, the boost of our processes, of our productivity by the means of AI, which really can make a big difference to every company, and those companies who do not apply these means for their productivity will be definitely wiped away within a few years by those who do. But that's not the topic for today. For today, I'd like to start with autonomous drive and the thought about end-to-end AI for autonomous drive. Well, what does that mean and why do we need that? If you would just consider to specify an autonomous driving algorithm for level 4 and level 5, that means to be applied everywhere at any time under each condition, that cannot ever be specified because you would never hit all the boundary conditions, corner cases, and whatever can happen in the world. You cannot describe the world comprehensively. That's just one reason why all those rule-based algorithms will never make it up to level 5 to at least our confidence. If you imagine to pass a pothole with a rule-based algorithm, again, difficult and hard to imagine. What does that mean? So today, when we look to the technology which is available so far, that's a laser, that's good. Then we are approaching level 2, level 3 somehow, barely with those rule-based algorithms, just labeling hundreds of thousands images and stating that's a tree, that's a car, that's a road, stationary, and then training a neuronal network in order to find out and to segment your images, and then everything is rule-based again until your track planner. That works barely, as I said, until level 3 perhaps, but of course today's technology already implies much more AI of the algorithm, but still with human-readable interfaces in between and ending up with a rule-based track planner. Still, that may work with a level 4 already in some trained ODDs, but you can imagine it will be hard to scale up to any other ODD or city or region, so it will be really challenging. So we believe that the only approach to really manage level 5 and to be really scalable to other ODDs, then you need to approach this end-to-end AI, where those interfaces between the different steps are not anymore readable by humans. So why should they? Because in your brain, if you imagine a speech center, an emotional center, the visual center, they also don't communicate in a human readable way. There's no reason behind that. Well, the situation for autonomous drive level 5 is the most complex you can ever imagine, what our human brain is capable of, and so the approach of our human brain would be the only means to really manage that. So there are several ways how this can work, and I can tell you it already works. So imagine you always need, of course, a very early low-level fusion of any sensor data perception technology you have on board. That's what you are doing as a human being as well. You are fusing your vision, your thoughts, your emotions, your acceleration, feeling, and whatever, and also your hearing. And then you enter the algorithm and then end up with a trajectory. That's it. And maybe during the development of such a system, you need those parallel decoders where you just, which you just need to debug your system to learn if there's something went wrong in this path, what the system may have seen so far. So it's a little bit like a little baby trains at first to run or to walk on feet, to learn to speak and so on. And later on, when it's 18 years old, it may even learn how to drive a car. So, but AI can do this much faster. Of course, the final step would be this approach. And then you don't need this debugging on board anymore. Of course, there are many questions still open. I can tell you we already trained a vehicle in Barcelona doing that, and it was a big surprise to us that it really smoothly already works, and it was capable to manage a roundabout without having seen anyone before. And when we transferred the car from Barcelona to Wolfsburg, to our headquarters, it also was able to drive there seamlessly. So that's really a promising approach, but however, you need huge amount of data for training, and you need, of course, tremendous amount of compute power to do that. So there's something to do, and also how to type release this kind of algorithm is also something which has to be worked out. And that's so our prognosis is that this may work to the end of the decade or the beginning of the next decade. But we are still ambitious on proceeding in that direction. And there might be a company which you know, Autobrains, who are also collaborating with us in that regard with a special approach in that direction. That's a different approach to what we followed on in Barcelona. Their recipe is to slice the elephant into many, many slices, which maybe then each single slice is then can be coped with pure end-to-end AI. So if you subdivide your problem into sub-problems, then it can be managed. So you can then scale it up again, adding more and more of those skills, like they call them. So that's also a promising approach, and it works already quite stable. Yeah, but there's a lot of more to do. When you imagine what you already can do with this vision language models, the VLMs, that's really amazing already for today's algorithms. So this is what you get from a normal labeling algorithm, those segmented images, just stationaries telling you which kind of object you are seeing here, but no relation between the objects. But if you imagine such a scene, just knowing that it's about a stop sign, the stop sign would mean a completely different meaning or also reaction you have to follow in any case here. And if you ask VLM, so vision language model, then this will answer you that in the left-hand case you just have to stop. In the middle you have to stop from both sides because it's a school bus. And in the right-hand side, it depends on where the stop sign is held. It means even either you can drive and pass the stop sign or not. So that makes a big difference. Or more simple example here, those are pedestrians, of course. That's easy to segment. But those pedestrians are just walking across a street along a crosswalk. So this is an important piece of information in order to predict the behavior of the objects. How do those vision language models work in principle? So that's maybe known to you, of course. So a large language model always just prompts the next most probable token to the tokens you enter. That's rather simple. But it needs, of course, to be fed by vision information. And that means you need a pre-trained vision model, which is somehow a little bit segmented already. Could be a video data bench, it could be an image data bench, and then mapped into the language model, and then you have a vision language model. That's a basic architecture. And that can be used already today to optimize your current AD stack via cloud operation, because this kind of vision language models are not able to run on board, of course, of our existing cars right now, but also for those kind of remote operation, which is also inevitable for autonomous operation, at least in the very first phase of introduction. And the basic principle is that you have to understand the scene here again. The prompt would be, or the question would be, the driver wants to take the highway on the left. That is the intention. What should he do? And the vision language model just delivers that there is a sign heading towards the next highway. At least in Germany it would mean that. And there are the lanes, the corresponding, and the system clearly says, okay, he has to change lane to the left. An easy operation, but not accessible for the current today's technology. Or if you think about this remote driving operation, if the car is stuck behind an obstacle or whatever, you can just subdivide the possible driving operations into standard ones, and then the system can recognize from the image just which you have to choose, and then in the car it's just operated. So that's what the envision is towards autonomous drive. And let me just give you a glimpse what is possible with the customer interface. Again, it's a huge cosmos already. So it's about emotion detection of the intention of the customer. It's about the connection and remembering of the customer's context and his digital environment. It's about detecting the environment, the ambient at all, and it's about also providing him then the service. And just to end, the means and the result is then what we call a get-to-know agent. And this get-to-know agent utilizing all this technology via AI in order to then provide the customer a dialogue in the car for his the user manual, augmented his ambient, and provide him any service he desires. Yeah, that's future mobility as we imagine it via AI. Thank you very much.